Today we are going to discuss descent below the decision altitude, DA, or minimum descent altitude, MDA, on an instrument approach procedure. We will look at the regulatory requirements when descending below the DA or MDA, and we will take this knowledge and apply it to 4 real-world scenarios. First, when conducting an ILS approach to minimums with an approach light system at Casa Grande Airport. Second, conducting an ILS approach to minimums without an approach light system at Phoenix Mesa Gateway Airport. Third, conducting a non-precision VUR approach close to minimums at Chandler Municipal Airport. And finally, conducting a circle to land in marginal VMC conditions at Falcon Field in Mesa. The regulation that stipulates when we can initiate a descent below the DA or MDA can be found in 14 CFR Part 91-175 Charlie. Here we are given 3 specific criteria that must be met in order to continue an approach procedure below the DA or MDA. The regulation states that no pilot may operate an aircraft below the authorized MDA or continue an approach below the authorized DA unless 1. The aircraft is continuously in a position from which a descent to landing on the intended runway can be made at a normal rate of descent using normal maneuvers. So depending on the type of instrument approach procedure we are conducting and the type of aircraft we are flying, there will be different considerations we must account for when determining when the aircraft is in this position. In the following scenarios, we will look at some different ways to determine when the aircraft is in this position. Number 2. The flight visibility is not less than the visibility prescribed in the standard instrument approach being used. Flight visibility is defined in the pilot controller glossary as the average forward horizontal distance from the cockpit of an aircraft in flight at which prominent unlighted objects may be seen and identified by day, and prominent lighted objects may be seen and identified by night. Therefore, this can only be determined by the pilot. In the following scenarios, we will look at some different ways we can determine flight visibility while we are in flight. Number 3. At least one of the following visual references for the intended runway is distinctly visible and identifiable to the pilot. First, the approach light system. There are a few different types of approach light systems, with the most common examples being the Malzer, ALSF1, and ALSF2. The majority of runways do not have an approach light system. These systems are more commonly found at larger airports or airports with a large volume of IFR traffic. If during the approach we get the approach lights in sight, this allows the pilot to descend to 100 feet above the touchdown zone elevation, TDZE. To descend below 100 feet above the touchdown zone elevation, we will need to get another component of the runway environment on this list in sight. However, if the approach light system is the ALSF1 and we see the red terminating bars, or the ALSF2 approach light system and we see the red side row bars, the pilot can then continue descent to the runway. If we are only authorized to conduct Category 1 procedures, seeing the red side row bars may still not be adequate to continue to land, but we will discuss this point further in a later scenario. If at any point during the approach we get the runway end identifier lights, or REAL, the Visual Glide Slope Indicator, VGSI, the runway markings, runway lights, the threshold markings, threshold lights, the touchdown zone markings, or touchdown zone lights, we can descend below the DA or MDA and continue descent all the way down to the runway. To recap, we must meet all 3 of the criteria outlined in 91-175 Charlie in order to initiate a descent below the DA or MDA. We must be in a position to make a normal descent to land using normal maneuvers, have the required flight visibility prescribed for the approach procedure, and have at least one of the components of the runway environment in sight to descend below the DA or MDA and continue down to the runway. The exception being the approach light system. As mentioned earlier, having the approach lights in sight will only allow us to descend down to 100 feet above the touchdown zone elevation. At this point, 100 feet above the touchdown zone elevation effectively becomes a DA regardless of whether the original instrument approach procedure was a precision approach or a non-precision approach. Upon descending to 100 feet above the touchdown zone elevation, we must either get one of the other components of the runway in sight, have the red terminating bars of an ALS F1 in sight, or the red side row bars of an ALS F2 in sight in order to continue the descent to the runway. Otherwise, we must immediately execute a missed approach. In addition to the requirements of 14 CFR 91-175 Charlie, we also have to abide by the requirements of 91-175 Delta when operating an aircraft below the DA or MDA. This regulation states that no pilot operating an aircraft may land that aircraft when the flight visibility is less than the visibility prescribed in the standard instrument approach procedure being used. Therefore, we must have the required flight visibility from descent below DA or MDA all the way down to landing on the intended runway. And finally, we have 14 CFR 91-175 Echo that dictates when we must execute a missed approach procedure. This regulation states that each pilot operating an aircraft shall immediately execute an appropriate missed approach procedure when the following conditions exist. Number 1. Whenever operating aircraft pursuant to paragraph C of this section, this is the 3 requirements we previously outlined to initiate a descent below the DA or MDA, and the requirements of that paragraph are not met at either of the following times. First, when the aircraft is being operated below MDA, and second, upon arrival at the missed approach point, including a DA, where a DA is specified and its use is required, and at any time after that until touchdown. This portion of the regulation requires that we meet all 3 of the requirements specified in 91-175 Charlie at all times when operating below the DA or MDA until we land on the intended runway. So if at any point after we descend below the DA or MDA, we find that the aircraft is not in a position to make a normal descent to land using normal maneuvers, the visibility drops below the required flight visibility, or we lose sight of the runway environment, we must immediately execute a missed approach. Number 2. Whenever an identifiable part of the airport is not distinctly visible to the pilot during a circling maneuver at or above MDA, unless the inability to see an identifiable part of the airport results only from a normal bank of the aircraft during the circling approach. So, if during a circle to land maneuver, we lose sight of the airport for any reason other than a part of the aircraft obscuring our visibility, we must immediately execute a missed approach. In this case, it does not matter whether the aircraft is above or below the MDA. If we lose sight of the airport when circling, we must immediately go missed. We'll discuss this topic further and how to execute a missed approach from a circle to land maneuver later in this video. Now that we have discussed the regulatory requirements for descent below the DA or MDA, we are going to apply what we have learned to 4 scenarios. In the first scenario, we are cleared for and flying the ILS-5 approach into Casa Grande under instrument meteorological conditions. Upon arriving at the DA, we have the medium intensity approach light system in sight, but we cannot see any other component of the runway environment. Can we descend below DA? In order to answer this question, we need to determine if we meet the 3 requirements specified in 91-175 Charlie. Number 1. Is the aircraft in a position from which a descent to a landing on the intended runway can be made at a normal rate of descent using normal maneuvers? In this case, the answer is yes. We are established on the localizer and the 3-degree glide slope of the ILS. Therefore, we are aligned with the runway centerline, and at 90 knots ground speed, we are in about a 500 foot per minute descent to maintain that 3-degree glide slope. This is about as good as it gets, and this is why a glide path is so valuable. If we are stabilized on an approach with the glide path, we will almost always be in a position to make a normal descent to land. In this scenario, the second and third requirements are intertwined. Remember, we need to determine, number 2, is the flight visibility greater than the visibility prescribed in the standard instrument approach procedure being used? And number 3, Do we have at least one of the components of the runway environment in sight? Well, the answer to the third requirement is yes. We have the medium intensity approach light system in sight, and having the approach lights in sight allows us to descend below DA. The answer to the second requirement is a bit more challenging. The required flight visibility for the approach is 1/2 statute mile. 1 statute mile is equal to 5,280 feet, so 1/2 statute mile is about 2,640 feet. Now we'll add the runway in for context. From our vantage point at the DA, 250 feet above the touchdown zone elevation, we are about 4,000 feet from the runway threshold. From this position, seeing the crossbar on the Mauser tells us we have more than 3,000 feet of visibility. We also have nearly the entire medium intensity approach light system in sight. And in the digital terminal procedure supplement, we can see that the length of the Mauser is indicated as 2,400 feet. Therefore, if we have nearly the entire system in sight, we have more than 2,400 feet of visibility from our position at the DA. So we do have the required flight visibility as well, but with only the approach lights in sight, we are only authorized to continue descent to 100 feet above the touchdown zone elevation. The touchdown zone elevation for runway 5 is 1,458 feet, so we are authorized to descend to 1,558 feet. This altitude is our new DA. However, in order to continue descent below 1,558 feet, we will need to get another component of the runway environment in sight. Remember, the Mauser does not have red side row bars or red terminating bars, so we will need to see one of the other components of the runway environment to continue our descent to the runway. As we continue the descent below the DA, our visibility along the ground continues to move forward, and after a few moments we get the green runway threshold lights in sight. We can now continue our descent to the runway for landing. In the second scenario, we are cleared for and flying the ILS 30 center approach into Phoenix Mesa Gateway Airport under instrument meteorological conditions. Upon arriving at the DA of 1,580 feet, we have the runway threshold in sight. Can we descend below DA? We will again apply the three requirements specified in 91-175 Charlie. First, is the aircraft in a position from which a descent to landing on the intended runway can be made at a normal rate of descent using normal maneuvers? In this scenario, the answer again is yes. We are established on the localizer and the 3-degree glide slope of the ILS at 90 knots ground speed and about a 500 foot per minute descent. The second and third requirements are again intertwined, and the challenge is determining the flight visibility. We need to determine, is the flight visibility greater than the visibility prescribed in the standard instrument approach being used? And do we have at least one of the components of the runway environment in sight? The answer to the third requirement is yes. We have the runway threshold of runway 13 in sight. Now, let's determine if we have the second requirement. On this runway, there is no approach light system, and therefore the required flight visibility for the approach is higher at 3/4 statute miles. 1 statute mile is 5,280 feet, so 3/4 statute mile visibility is approximately 3,960 feet. In this case, we need to determine how far down the runway we would be required to see to determine that we have the required flight visibility. Now, we are going to do some math here to figure out how far down the runway we need to see from our position at DA. But wait, don't stop watching. The good news is you do not have to do math when you arrive at DA. This exercise is meant to demonstrate that if you are flying a typical ILS approach with a decision height of 200 feet to a runway without an approach light system, the required flight visibility is going to be 3/4 statute miles, and the answer we find to this solution will work in every one of those cases. Looking at the approach plate, we can determine that when we arrive at DA on the glide slope, we will be 200 feet above the touchdown zone elevation on a 3-degree glide slope. We see in the profile view of the approach plate that the 3-degree glide slope will give us a threshold crossing height of 41 feet. We can use this information to determine our horizontal distance from the runway when we are at the DA on a typical ILS. We will do this by subtracting the threshold crossing height of 41 feet from the height above the touchdown zone, or HAT, at DA, giving us a new triangle with a height of 159 feet. We can now use this new triangle to determine our horizontal distance from the runway at DA by taking the height of the triangle, 159 feet, and dividing by the tangent of 3 degrees, the glide slope, and the result is 3,034 feet, which is our distance from the runway when we are at DA. We can now subtract our distance from the runway, 3,034 feet, from the required flight visibility, 3,960 feet, to determine how far down the runway we would need to see, which is about 926 feet. So, we would basically need to see the aim point markings to know that we have the required flight visibility for the approach. If we only have the runway threshold in sight, we do not have the required flight visibility. In this scenario, we only meet 2 of the 3 requirements to descend below DA, so we cannot continue the approach, and we should immediately initiate a climb and execute the published missed approach procedure or an alternative missed approach procedure provided by ATC. On to our third scenario. Here we are cleared for and flying the VOR 4-right approach into Chandler Municipal Airport under instrument meteorological conditions. After crossing the final approach fix, we descend to the MDA and continue to track the final approach course inbound. As we approach 1.2 nautical miles from runway 4 right, we get the runway threshold in sight. Can we descend below the MDA? This scenario is different from the previous 2, where determining the flight visibility was the challenging aspect. In this case, the challenge will be with the first requirement of 91-175 Charlie. Is the aircraft in a position from which a descent to landing on the intended runway can be made at a normal rate of descent using normal maneuvers? Well, we are 1.2 nautical miles from the Willie Vortac and now have the runway threshold lights for runway 4 right in sight. So we've met the third requirement of having the runway environment in sight, and the second requirement, which in this case is to have 1 statute mile flight visibility. On the profile view of the approach plate, we see that there is a V symbol 1.4 nautical miles from the runway threshold. This V symbol is a visual descent point, and we are 0.2 nautical miles past the VDP. So, are we in a position to make a normal descent to land? Well, to answer this question, we are going to look at it from a few different angles. We'll look at what, if any, guidance there is about the VDP in the regulations or the AIM. We'll also calculate the required descent gradient from our current position and determine what average descent rate would be required to follow that gradient. Finally, I'll unfreeze our video and we'll see if I was able to land using a normal rate of descent and using normal maneuvers. No pressure. So, let's look at the regulatory and advisory guidance. Well, there is nothing in the regulations that mentions the visual descent point. The AIM is a little more helpful. In section 545 Hotel 3, we have some advisory guidance for the exact scenario we find ourselves in. The AIM states, on a straight-in, non-precision instrument approach procedure, descent below the MDA between the visual descent point and the missed approach point may be inadvisable or impossible. Aircraft speed, height above the runway, descent rate, amount of turn, and runway length are some of the factors which must be considered by the pilot to determine if a safe descent and landing can be accomplished. So, let's determine these factors in our scenario. Well, our current ground speed is approximately 90 knots, and something to keep in mind, in our Cessna 172, we will not maintain 90 knots during our descent to the runway. We will slow to approximately 65 knots as we leave MDA and fully configure the aircraft. Next, we see in the profile view that our height above the touchdown zone at the MDA is 440 feet. So let's determine the required gradient from our current position to descend to land on the runway, and then use this value to determine the descent rate. So our aircraft is 1.2 nautical miles from the runway and at an altitude of 440 feet AGL. we can use this information to determine the descent gradient to the runway by dividing 440 by 1.2. And we find that the required descent gradient is about 367 feet per nautical mile. This descent gradient would get us to the ground by the runway threshold, but we'll plan on touching down closer to the aim point markings, so the actual gradient required to descend to the touchdown zone is even shallower. Next, we can use the required gradient and our ground speed to figure out the rate of descent required. To do this, we will use the quick reference climb descent gradient table in the back of the Digital Terminal Procedure Supplement. Using this table, we can see that a descent gradient of 370 feet per nautical mile when traveling at 90 knots ground speed would only require a 555 foot per minute descent rate. In reality, we will be slowing the aircraft to our final approach speed of about 65 knots as we descend, which will have the effect of reducing the descent rate required. So, we can see that we should be able to descend at a normal rate to the runway. While company standard operating procedures in some cases may not allow a descent after passing the VDP, particularly in higher performance aircraft, we can see that in this scenario at least, we meet all three requirements to descend below the MDA, so we can continue the approach and descend down to the runway.